Okay, so just a little disclaimer for this last problem. I didn't realize that the review said the following. This is a different book, so these pages will not match up. I don't believe, unless for some reason they did. But since we're doing hypothesis testing, we're doing this case is going to be a mean, two sample mean test. I'm going to give you some data. You're going to plug it into a calculator. You're going to look at the hypothesis test and figure out what it wants. Another thing to note, this is going to be broken into parts just like the other one was. You're going to have to answer all of the following: H naught, H1, and so on and so forth. So let's do that. If we look, we're looking for H1 in the hypothesis. So it says the statistics are summarized below. Use a 5% significance level to test the claim that the mean IQ scores of people with low lead in their blood is higher than the high lead levels than those with the high levels in their blood. So I think H naught is going to be the mean is equal to the mean 2, and then the H1 is the mean. We want to have the IQ score of people with low lead levels in their blood is higher, so that's greater than the mean 2. If we want to do the p-value, we're going to go stat tests 2 sample t-test. Actually, yeah, I think so. This is not a data, this is a stat. And you should see where you can enter all of this information. So let's enter it. I mean, that's kind of how this works. If you don't see where you're supposed to enter the information, it's not helpful, although sometimes you have to make a decision whether or not everything is useful in the problem, and that can sometimes throw you off. But so we enter that 17.3423, 21, next one, 89.734. And then 78. We want greater than, so that would be this one. Pooled just means they come from the same pool, and we're going to assume not. So 0.9367. 0.9367 is our p-value. So that's a 93% chance. Based on your p-value, which is larger, p is obviously going to be larger in this case. P is greater than alpha. Test it using a confidence interval. To do that, we're going to go to the same pot. Stats, tests. This is a 2 samp z int, or t int, sorry. So we've got all the same information, 95%. Make sure that you look at that. So these problems won't match up either. So you might have different n's and stuff. So you have to look for each individual case. You have to look at what n is given to you. You might have to change it on your calculator. I'm not going to in this because I'm only going to use the one problem. But with this being said, negative 14.93 up into 0.01. Not 1.9551. Sorry, I read the wrong number. 1.9551. And so since 0 falls in this interval, that means there's no change. So that means we fail to reject the null. And they must be about the same in this case with these numbers that I've given you. So we would say that there's not enough evidence to show that that low levels of lead in the blood have a higher IQ difference. Remember, these are just comparing the differences, so there is no indication that the low levels of lead in the blood gives you a higher IQ than the other ones. So thank you guys for watching.